Hi guys, my name is Jason Zhang. I am a rising senior at the Gatton Academy of Mathematics and Science in Kentucky, and I'll be teaching this chemistry course. Today, we're gonna have our introduction to chemistry. So for this course, we're gonna have 4 main units. The first one is Introduction to Chemistry, which is just today. It's a short unit and it just covers the basics of chemistry. Unit 2, we're gonna look at the atoms, molecules, and matter, and look at the periodic table more in detail. Unit 3 is the most math heavy. If you like math, stoichiometry would be pretty easy to you. It's a lot of calculations based on math. And Unit 4 is basically chemical reactions, where we'll learn how to predict products of basic reactions. So that's the roadmap of this course. For today, we're going to learn how to define chemistry and why chemistry is useful. We're going to learn the conservation of mass and use it to apply challenging problems. And for today, the biggest part is about significant figures. We're going to learn how to calculate significant figure and do addition and subtraction with them. And then we're gonna finish off by conversion between SI units, which is the metric system. The US uses units like feet and pounds, but the rest of the world uses different systems like meters and those types of stuff. So we're gonna learn the metric system, and then we're gonna learn what density is. So advice on the course, I would recommend everyone to take brief notes because chemistry has some theoretical stuff as well as some calculation. I would take brief notes for all the definitions. And then while we're doing problems, I would recommend you trying to solve them on your own paper as well while I work on them on the board. In this class, for the problems, I'm going to ask you guys to type in your answer in the chat when we get up to the problems. So I would recommend using the chat to type in your answers when we come to those problems. I'll tell you later when to type in the chat. And then after the end of this class, there's going to be an optional homework posted on Google Classroom. It's like 15 multiple choice questions. You fill out a Google form and you can see if you learned the material covered in this course or not. So let's start. So defining chemistry. So before we can define what chemistry is, we need to understand what matter is. So what is matter? So matter is anything that takes up space and has mass. So some examples of matter are like an iPhone. It has space and it takes up mass. A paperclip, although the mass is really small, it still takes up space and has mass. And even ice. So matter is basically anything you can touch in this world. So now I'm going to define what chemistry is. So chemistry is the study of matter and the reactions they undergo. So the study of matter is we identify what matter is made out of, what's the structure of matter, what are some properties of matter, and then what reactions the matter undergo. So for example, if we're studying paper, we can study what paper is made out of. We can say paper is made out of trees, and trees are made out of carbon, so we can look at the structure of paper. And then for the second part of the definition, reactions they undergo, we can look at burning paper. So after burning paper, we convert the paper into ashes and gas. Now I'm going to talk about why study chemistry. So chemistry helps explain natural phenomenon. So basically, one of the interesting things about chemistry to me was how little spiders can walk over water. I always thought it was cool because humans can't walk on water, but the little spiders can. And then another thing that I thought was interesting was photosynthesis, how plants can make their own food. Like, it's just an interesting process. So chemistry can help us explain both of these phenomenon very well. So another reason why you study chemistry is chemistry can create drugs to improve people's lives. I know there's a lot of people who study chemistry to get into pre-med, pre-pharm degrees once they're in college, and chemistry is essential to like making new medicine. And chemistry is just related to so many other fields like biology, medicine, environmental science, and even math and physics. When it's related to biology and medicine through drugs and pharmaceuticals and understanding how the reactions occur. And with math and physics, it actually looks at the definition of an atom, and they use mathematics to define an atom. But we won't get into that in this course. So our first thing we're going to do is conservation of mass. So the conservation of mass basically says that a total mass of a chemical reaction stays the same. So if we start out with products A1 and A2, and we react it to form products B1 plus B2, we know that the mass of the left side and the mass of the right side are equal. So these masses are equal. So if we have like 10 grams on the left side, then after any reaction, we know that the products, there's also going to be 10 grams. So we can use that to our knowledge and use that for problem solving, because the left and the right side are equal by the law of conservation of mass. So in the next slide, we're going to have an application of this problem solving. So the question is, James places 1.5 grams of paper in a vessel with 8.5 grams of air, and he seals the vessel tightly. So that means there's nothing else in that vessel except for paper and air. And then he burns the paper, so the products are ash and air. And we're told that he has 0.25 grams of ash, and we want to find the mass of the air. So I want you guys to think about how you can solve this problem. If you have any ideas, please post it in the chat below. Okay, yep, you guys did it correctly. I'm gonna go over the full problem out loud. So we're basically, in the reaction, we start off with paper. And we also have air. And then this arrow means a reaction. So in the end, we have ash and air. Notice how I put the air in different colors, because it might not be the same amount of air in the beginning and the end. So we know there's 1.5 grams of paper and 8.5 grams of air. And at the end, we know it's 0.25. By the conservation of mass, we know that the sum of the left equals the sum of the right. So we can let the end of the error be x. And we could solve this equation to get x equals 9.75 grams. So that's basically how we use the conservation of mass to solve a problem. You guys all did it right in the chat. So let's go to the next problem. Okay, so now we're going to learn what the states of matter are. So there's 3 main states of matter in chemistry. I know that physics, sometimes they consider plasma as an additional state, but the 3 states of matter are solids, liquids, and gases. Solids have fixed shape and volume, so they don't change its volume or its shape, but they're the most common items we see, like iPhones or anything we basically touch, like computers and books. Liquids have fixed volumes, but not fixed shape. So that means it takes the shape of the container, like water and beverages, they're all liquids. And gases have no shape or volume, so they just fill up the whole entire room, like gases. So here's a diagram of the solids, liquids, and gases. Solids, as you can see, they're like tightly packed together and they're in an orderly lattice. Liquids are more miscible. It's not as tight as solids. It can move around. And gases are just like free floating particles that just take up the shape of the container as it is. So now we're going to learn what a physical change is versus a chemical change. A physical change is a change of matter, but not identity. So you change the form of the matter, but not the identity. For example, if we talk about a piece of paper, we can crumble it up, we could tear it, we can rip it. That's all a physical change. The paper is not changed. It's still paper. But a chemical change is where you change the identity of the matter. For example, if you burn it instead, then it changes the form of the matter. It's not paper anymore after you burn it, it's ashes, and it converts some of the paper into gases. So basically, physical change, it's still that substance in the end. A chemical change, it's a completely different substance. An easy way to see chemical changes is if they say you create something new. That's usually an indicator of a chemical change. So now I'm going to talk about elements. So elements, so first of all, the thing below the picture is a periodic table. So this thing below is a periodic table, and each one of these rows, each one of these squares is a unique element. Like this is hydrogen, helium, lithium, beryllium, boron, carbon, and so on. Pure substances can't be broken down into simpler substances. And these are all of the known ones, except in recent years, they discovered 113 to 118, and they're new elements. But this is just an old picture of a periodic table. So that's what an element is. A compound, it's a substance comprised of 2 or more elements, chemically combined. A common example of that is table salt, which is NaCl. It's basically where sodium and chlorine chemically combine to form salt. So it's just two or more compounds, two or more elements forming together. Another example of a compound is hydrofluoric acid. It's commonly used in like horror movies and such, where it burns away skin. It's where hydrogen and fluorine are chemically combined. Another example of a compound is carbon dioxide, which is the gas we exhale. It's where carbon and oxygen combine and form that gas. So elements, just one of these things on a periodic table, were compounds, two or more. That's the key. It's two or more elements combined together. So let's recap elements versus compounds. Elements are pure substances that can't be broken down. So that's the periodic elements. And compounds are two or more of them. So now we're going to get into the hard part about the lecture today, in my opinion. It's understanding what measurements are and significant figures. So you might be wondering, why do we care about significant figures? The thing is, in the lab, if you measure something over and over again, you might not get the exact same number due to experimental error. So significant figures helps deal with that. For example, if you're measuring this Visa card right here, you might see it's like just about 8.52 centimeters. But then you might realize that it's not totally aligned here. There's a slight difference and it might change it based on sliding it down a little. Oh, I had a question. I just realized it says, why are compounds classified as pure substances when they consist of two or other pure substances? The reason is when they combine in a definite form, and it makes it, and it, oh, can you guys please stop drawing on my screen? Thank you. A pure substance basically means it's only one thing in the chemical environment, and it's not like there's multiple different things in the chemical environment. So I'll go back to it since there's questions about. So elements like a pure thing, but the compounds, they chemically react and then they form one pure substance at the end. So it's made out of, it was initially made from a pure substance, but when it reacts, it creates a new substance. So compounds, they react and then it's pure at the end because it's just made out of one substance. So that's what pure substance meant. Okay, now that we got that out of the way. So about significant digits, as I said before, you can like move it to the left and you might get a slightly different number. So that's why we have to use significant figures. So measurements in the lab. So we want to, it's different than like math class when you're measuring. For chemistry, you write down all the known digits and then you estimate one additional digit. Like, for example, the smallest scale on this ruler that we have is 1 centimeter. So we write down our known, which is 2, and then we add one more digit. And we estimate one more digit. So you could say this one's around 2.3. Or you could say it's around 2.2. They're both acceptable since you're estimating that last digit. But the one thing you can't do that I've seen in the chat is you can't say like 2.33 because that's implying that we know to the 10th place, when in reality we don't have a 10th place ruler. So we can't say it's 2.33. We can only estimate one additional digit. Okay, so we can't estimate more than one digit. And notice how in chemistry, we use the metric scale, we use centimeters, and we don't use like inches or that kind of, or feet. We use centimeters, meters, millimeters, kilograms, and so on. So just remember, when you're in the lab and you're looking at a ruler, you measure to one additional digit. Okay, now we're gonna get into the hard part. We're gonna do rules for significant digits. So our first rule is all digits are significant if they're not 0. So basically, if we have a number 81, 8 is a non-zero digit and 1 is a non-zero digit. So they're both significant. Our next rule is the only hard part about significant digits are the zeros. So zeros at the beginning of the number or zeros at the end of the number may not be significant. So what does beginning of a number mean? So if you have like 081, we have like a leading 0 here, and they're not significant since it's leading. Similarly, if it's like at the end of a number, it may not be significant. We're going to look at future rules to determine if like at the end, if they're significant or not. But for now, we just need to notice that zeros at the beginning or the end may not be significant. But if it's in the middle of a number like 801, it is significant, as well as the 8 and 1. So we only consider zeros not significant if it's at the beginning of a number or if it's at the end of the number. That's the only time. What about 2 zeros? It says in the chat. So if it's 2 zeros within a number, they're both all significant. But like if it's 2 zeros outside of a number, we can just simplify that number to 81 and like not even consider the numbers because they're not significant. If it's at the end, like 8100, we're gonna have to look at further rules to determine if these 2 zeros are significant or not. And there could be like 3 zeros in the middle, 4 zeros in the middle, 5 zeros in the middle. It really doesn't matter. We just have to look at if it's in the beginning, it's not significant. And in the end, we have to use further rules to determine if it's significant. And the last, and another rule is zeros between two significant digits are significant. So like if we have like 9, 0, 0, 0, 1, we know 9 is significant, we know 1 is significant, and everything between must be significant. So that's how it works. So any number, any zero between any two significant digits are significant. So I want you to type in the answer in the chat. How many significant digits are 9.02, 0.902, and 0.000902? Just type your answer separated by commas. I see some confusion in the chat. Yes, all of them have actually 3 significant figures. Let's go over why with the rules that I've listed above. So first, we know all digits that are 1 through 9 are significant. So this one is, and this one is. And then rule number 3, zeros between significant digits are also significant. So this is also significant. So the first one has 3. For the second one, zeros at the beginning are not significant. So this is not significant. But the 9 is significant, the 2 is significant, and everything between is significant. So this 0 in between the 9 and 2 are significant as well. For the third one, all of these 4 leading zeros are not significant, because the rule number 1 says beginning, zeros at the beginning are not significant. But all 3, these 2 are significant just like the above, and anything in between is significant. So there's 3 significant digits for all of them. Does everyone understand now? Sophie, do you have a question? You can unmute your microphone and ask.
Okay, now I can unmute. So why did they even invent these significant rules? So like 9.02 is not the same as 0.902, which is not the same as 0.000902.
Okay, well, they're not, well, significant digits is basically a rule to calculate, like I said in the previous one, to calculate how many digits you use to carry out due to experimental uncertainty. These 3 numbers are not the same, but I was just asking like 3 questions in a row, kind of. They're not related at all. A significant digit, how many significant figures does not make every number equal. It's just a way where in the future we can do more calculations. Do you understand now? Sophie, does that make sense? Okay. So there's 3 for all of them. So how about for the next one, 0, 4, 7, and 4, 7? How many significant figures are there? Please type it in the chat below when you figure it out. It's good. I see a lot of correct answers. So let's work through them together. So this 0 is a leading 0. It's not significant. Leading zeros are never significant. And 4 and 7 are both significant digits. So there's 2 in the first one and 2 in the second one as well. So there's 2 significant figures for both of them. Yeah, I know. The second one's easier than the first one, but we have more rules in the future, like right now. So now we're going to clarify ending 0 rules, because ending zeros are kind of harder. So ending zeros after a decimal point are significant. So how many significant figures do you think is in this example? 90.0 centimeters. Yep. So we basically use the last rule, ending zeros after a decimal point are significant. So this 0 is significant, and we know 9 is always significant. And then on the last page, any number between 2 significant digits are significant. So this 0 is also significant. So we have a total of 3 significant digits. Does that make sense to everyone? Okay. How about this one, 0.09 centimeters? Please type in your answer in the chat. Okay. I put in this example as like a tricky example. Because this 0 is technically considered a part of the leading zeros. So there's actually only 1 significant digit. I should revise the statement. Ending zeros after a decimal point are significant only if there's a non-zero digit before, to the left. So there must be a non-zero digit to the left. To the left. So like in this case, there was a non-zero digit to the left, which is that 9. So this 0 was significant. But in this case, this 0, there's no non-zero digit to the left. So this is a part of the leading zeros. So there's actually only 1 significant figure. I'm sorry for the confusion I caused. And then how about this one? Using my modified version of the rule, how many significant digits are in 0.90 centimeters? Okay, good. So remember, this 0 is a leading 0. So it's not, this is a 9, which is always significant. And then this one, it does have a non-zero digit to the left. So this one's significant. So there's 2. You guys did pretty well. Okay, so let's recap all the rules. All digits are significant with the exception of possibly zeros. We have to consider zeros deeper. Zeros at the beginning are never significant. Zeros at the end, we have to check. And any zeros between any significant digits are significant. And ending zeros after a decimal point are significant if there is a non-zero digit to the left. So that's basically all the rules. And now we're gonna have practice. So for A, how many significant digits are in 202? Good job, everyone. There's 3. So all non-zero digits are significant and anything between significant digits are significant for a total of 3. How about B? Okay. Yep, I'm seeing 3 because all of these are significant digits. How about C? That one's kind of tricky. Be careful that there's a decimal point here. If there's a decimal point, it basically means every single number is significant. So that's one thing to keep in mind. C, there's 3. How about D? Okay, in the chat, I see that. Most people said 4. Yes, these 2 are leading zeros. They're not significant because there's not a non-zero digit to the left, and all of these work. E is 1, yes, because these are leading zeros. F is 1, and how about G? Yep, these 2 are not, and all 6 of these are. So there's 6. I hope these were pretty easy for you guys. In the homework, there's going to be a lot more questions like these where you can practice. So now we're going to learn how to multiply or divide. Frequently in chemistry, we're going to have to do lots of calculations, and we want to be able to keep the right number of sig figs. So for the rule of multiplication or division, you report your answer in the same number of sig figs as the measurement with the least number of significant figures. So first, for the two questions, you're going to have to realize how many significant figures are in each. So how many significant digits are in the first one, 5.1? Can you please answer it in the chat? Yep. And how about the second one? Yep. There's 2 in the first one and 1 in the second. So we want to take the least number of significant figures, which is how many? Do we round our answer to 1 or 2 at the final answer? Yep, I see you guys got it right. The least number is 1. So what we do is we put this in a calculator, or if you could do it in your mind, you can multiply it out 0.51. You take the whole thing, and then you round it to 1 significant digit. In this case, that is this digit right over here. So it's 0. You report your answer as 0.5. Note that if you report your answer as 0.51, that would be incorrect in chemistry since we have to do the least number of significant digits. And it's the same for division. There's 2 significant digits in the first one and 1 in the last one. So we round it to 1. 5.1 divided by 0.1 is 50. And 50 only has 1 significant digit. So that's good. But addition and subtraction, they're kind of different. For them, you have to give the same number of decimal places as the digit with the least number of decimal places. So we don't care about significant digits. We care about the least number of decimal places. So what place is the first one? How many decimal places do we report to for the example 1? Yep, 1 decimal place. Yes, that's right. Because this one only has the 10th place, and this one has the 1000th place, but we want to keep the least number of decimal places, so that's 1 decimal place. So we use a calculator, we add it up, we get 6.122, but we only keep it to the 10th place, and we report 6.1. It's different than multiplication and division, I do know that. And the second one, oh, this one's kind of tricky. Because there's, how many significant digits are in the first in 20? Yep. Yeah, that's right. There's only one significant digit in 20 because that 0 at the end is a leading 0. So when we actually do the subtraction, we get 5, but we only report it to the tens digit because that's the least number of decimal places, which is 0. But then we have to round up that 5 to equal 10. Yeah, chemistry can be different than math sometimes. So why don't we do A? You can use a calculator for this. So how many? So the first step to do is like put in a calculator and get the rounded answer that a calculator puts out. So in this case, I put it in my calculator and I got 5.808. But then we have to realize that this one has hundredths place and this one has thousandths place. So we report to the hundredths place since that's the least. And since there's an 8 behind, we round up and get 5.81. I realized in the chat some people said like 5.8 or 5.80. Make sure you follow the rules. It's 2 decimal places since that's the least number of decimal places. So it's 5.81 and you have to round. How about the second one? B. Yep, it's 0.37. It's just subtraction. You realize it's 2 decimal places on both. So you keep 2 decimal places and it's just 0.37. And how about C? So C, this one has 2 decimal places and this one has 3. So we're going to keep it down to 2. And after doing the calculations, you get from a calculator 2.475. And we round it to the 2 decimal places. So we round it to 2.48. Okay, D's actually tricky since we're doing like 2 things in once. So when we have multi operations, we have to do this one first. And then we do the multiplication and we keep track of how many sig figs are in each. So since the parentheses are first, we do 38.91. And then the sig figs for this one, we notice that we round to 2 decimal points. But for a calculator, we keep everything in. So after we do the subtraction, we get 38.01 times 0.08. And then we get final answer of 13.1128. And then we round it to 3 decimal places, so it's 13.1. This is a parentheses, not 10. I'm sorry if my handwriting's kind of bad. It's 0.08, not 10.08. Oh wait, sorry, my bad. It's 3.11. So it's 3.11, not 13.11. I made a typo in my calculator. Okay, let's do E. So we can put this all in our calculator, but we have to remember when we're multiplying or dividing, we take the least number of significant digits as any of these. So this one has, how many significant digits does this first number have? 2.568. Yep, it has 4. How about the second one? 2, yes. And the third one? 4. So how many significant digits do we report at the end? Yep, we report the least number, which is 2. So we can just put this whole equation in your calculator and just round it to 2 decimal places. So I got 3.558 repeating and more decimal digits. And then we round it to 2, so we get a final answer of 3.6. Does everyone understand how significant digits work now? Can you type in the chat if you're confused? Okay. Guess we can move on now. Okay, this is from a chemistry competition. I'm not sure if many of you have heard about it. It's the Chemistry Olympiad. So they're like, the Chemistry Olympiad's kind of like the USAMO of math competitions. And it also has a camp at the very end if you do well. And this is a problem from that the local exam actually. Sorry, there's 2 exams, the local and the national. The local is like the easier one, the one you have to do first. And this is one of their questions. It says, how many significant figures should be reported in the answer to the calculation? 12.501 times 3.52 over 0.0042 plus 6.044. Does anyone have any ideas on how to start this problem? If you do, can you please type it in the chat? Calculate each part separately. Yes. We can, let's first calculate the top part, which is actually multiplying these 2 digits together. How many significant digits do we keep in that on the top? Yep. We keep 3 digits in the top. So what answer are you guys getting for multiplying the top? Oh, we're doing one step at a time. Right now, we're just multiplying these 2 top numbers. So I'm getting 44 after rounding. 44.0, yes. After rounding on the top. And then let's do the division on the bottom. How many significant digits do we put? Do you guys have a phone or something? You can type it in a phone. No. Okay, then I guess I'll do the calculations. How many significant digits do we keep after dividing by 0.0042? Yep, 2. So we get, after doing it, it's 11000. Here's the tricky part. We're gonna have to add 6.044. But the thing is, remember when we're adding and subtracting, we use the digit with the least significant digit. So basically it's the thousands digit plus the ones digit. So this is the least specific. So actually when we add 6.044, we still get the exact same number, 11000. Because this one's less specific. So adding 6.044 is basically like adding 0. Because this is the thousands digit and we're not adding anything to the thousands digit or anything close, so it could round up. So how many significant digits are in 11,000? 2, yes. So that's why the answer is 2. Can you type in the chat if you understand how to do this problem now, or are you still confused? If you're confused. Okay, that's good. Now, the last topic we're going to talk about is converting between SI units. Do any of you know the metric system? Please type in the chat if you know the metric system. Okay. So basically all we're going to do is simple calculations within the metric system. It's a lot easier than significant figures, in my opinion. So there's these metric prefixes, and I use that. I don't know if there's any other acronyms, but I use the acronym King Henry doesn't usually drink chocolate milk to remember the metric system. So the first letter is the first one stands for kilo, hecta, deca, unit, deci, centi, and milli. So that's how I remember how to convert the units. 1 kilogram is like 1,000 grams. Hecta is like 100. Deca's 10. Units 1. Deci's 0.1. Centi's 0.01. And milli's 0.001. So basically 1 like kilogram equals 1,000 grams. So if I asked a question like how many kilograms is in 5 grams, what's the answer to that? How many kilograms are in 5 grams? Yep. I see the correct answer in the chat. So one way to do it is use this conversion factor, and you can put 1,000 grams and 1 kilogram. And you could cancel out these units. Well, we're multiplying by 1 kilogram over 1,000 grams because it equals to 1, since we know it's true. So we get 1 over 200 kilograms. So that's basically how we're going to solve all of these problems. So can everyone do the first problem on this page and type your answer in the chat. What is 0.725 kilograms in grams? Okay, that's good. We have to remember 1 kilogram is 1,000 grams. And we can have 0.725 kilograms. 1 kilogram is 1,000 grams. And we can get 725. So that's pretty good. How about the second problem? What is 0.25 millimeters in meters? Please type it into the chat when you have time. Yep, that's right. You basically just divide by 1,000 and get 0.00025. That's good. We're almost out of time, so let's do these two as the last questions. So what is 5 grams in kilograms? Can you type that into the chat? Yep, 0.005 kilograms. And how about the last one? 10 liters in milliliters. Yep, 10,000. Yep, that's right. So basically, everyone here is pretty aware of how to convert units. So let me skip through the next few slides. Here's a chemistry joke to end, meme to end the day. Are there any good chemistry memes? I don't think so. I thought that's pretty funny, in my opinion. And then the lesson recap. We defined what chemistry is. We learned the conservation of mass. We learned significant figures, and we converted between different SI units. We didn't have enough time to cover density today, but I'll do that next lesson. And then if you have any questions or suggestions how to improve, any suggestions how I can improve my lectures, please feel free to email me at jasonzhang@alphademic.org. I'm going to post these PowerPoint slides on Classroom, and then there's an optional homework that would be uploaded on Classroom today as well. Thank you guys for watching.